Imagine looking at a map and realizing that an entire country shouldn't exist. Not because it was conquered, not because it was discovered, but because it was built. Right now, millions of people in the Netherlands are sleeping, working, driving, and raising families on land that was once completely underwater. Some of the country's busiest cities, its largest airport, its richest farmland, and even entire provinces sit below sea level. If the pumps stopped, if the barriers failed, or if the sea reclaimed what it once owned, vast parts of the country would slowly disappear beneath the water. No nation on Earth depends more on engineering simply to exist. For over 1,000 years, the Dutch have been fighting a war unlike any other. Not against another country, not against an invading army, but against the North Sea itself. And somehow, they've been winning, using medieval windmills, massive walls stretching across open water, the world's most advanced flood barriers, and engineering projects so ambitious, they literally created new land where none had existed before. Today, around 17 million people call this impossible landscape home, a nation where nearly 1/3 of the country lies below sea level, yet remains among the safest places on Earth. This is the unbelievable story of how the Netherlands reclaimed an entire country from the sea. Look at a satellite image of the Netherlands. At first, it appears like any other European country. Modern cities, highways, airports, farms, wind turbines, one of the busiest ports on Earth. But hidden beneath this peaceful landscape is one extraordinary truth. Much of it doesn't naturally belong there. If every dike, every pumping station, and every flood barrier suddenly stopped working, large parts of the country would slowly disappear beneath the North Sea. Some of the world's busiest cities would flood. Millions of homes would be threatened. Entire airports could become lakes. The Netherlands exists today, not because nature allows it, but because engineering makes it possible. Every single day, thousands of pumps move millions of cubic meters of water. Massive barriers stand ready for incoming storms. Hundreds of miles of dikes silently protect the land. This isn't simply flood control. It's one of the largest engineering systems humanity has ever built. But none of it existed 1,000 years ago. Back then, the sea always won. Long before modern cities, the Netherlands looked completely different. Much of the region consisted of marshes, peat bogs, mudflats, and tidal wetlands. Twice every day, the North Sea pushed salt water deep inland. Storms regularly destroyed villages. Farmland disappeared overnight. Entire communities were forced to relocate. For early settlers, life was a constant struggle. People couldn't simply build houses wherever they wanted. Instead, they created artificial hills called turpen. These raised mounds lifted homes above seasonal floods. It wasn't a permanent solution, but it bought them time. Generations lived knowing that one powerful storm could erase everything they had built. As populations grew, small villages began connecting these raised areas with simple earthen walls. At first, the barriers were only meant to protect nearby farmland. But every successful wall encouraged people to build another. Small dikes became longer. Longer dikes connected neighboring communities. Eventually, entire regions were surrounded. For the first time, people weren't simply surviving beside the sea. They were beginning to control it. It marked the start of one of humanity's longest engineering projects, a project that continues even today. But building dikes solved only half the problem. Keeping the water out was much easier than getting rid of the water already trapped inside. And solving that challenge would lead to one of the greatest inventions in Dutch history. By the Middle Ages, the Dutch had built miles of dikes. The sea could no longer flood the land as easily. But another problem quickly appeared. Rainwater, groundwater, and river water became trapped inside the dikes. The protected land slowly turned into a giant shallow lake. Without a way to remove that water, the reclaimed land would eventually flood from the inside. At first, people dug canals by hand. They used buckets and simple water wheels. But as villages grew, those methods became hopelessly slow. Then, the Dutch transformed a familiar machine into something revolutionary: the windmill. Most people associate Dutch windmills with grinding grain, but many of them were built for a completely different purpose: pumping water. Large wooden scoop wheels, and later Archimedes screws, lifted water from low-lying fields into canals. From those canals, the water flowed into rivers and eventually reached the sea. One windmill could move thousands of gallons every hour. Several windmills working together could drain entire regions. Suddenly, land that had been underwater for centuries became usable farmland. It was one of history's earliest examples of large-scale environmental engineering. The Dutch weren't simply adapting to nature anymore. They were redesigning it. Draining water was only the beginning. The Dutch soon realized something astonishing. If they surrounded a section of shallow sea with strong dikes and continuously pumped the water out, they could create entirely new land. This reclaimed land became known as a polder. A polder isn't natural land. It is land built by engineering. The process sounds surprisingly simple. First, engineers construct a circular dike around the chosen area. Next, the enclosed water is pumped out. As water levels fall, the muddy seabed slowly dries. Roads are built. Drainage canals are added. The soil is stabilized. Eventually, what was once open water becomes farmland, villages, or even entire towns. One of the most famous examples is the Beemster polder, completed in the early 17th century. It transformed a large inland lake into fertile agricultural land. More than 40 windmills worked together for years, removing millions of cubic meters of water. When the project was finished, an entirely new landscape had appeared where boats once sailed. Perfectly straight roads, geometric canals, productive farms, thriving communities. It was unlike anything Europe had ever seen. For the first time in history, an entire region had been designed almost from scratch. The Beemster became proof that humans could reshape geography itself, and it inspired even more ambitious dreams. If one lake could be reclaimed, why not something much larger? That question would eventually lead the Dutch to attempt one of the greatest civil engineering projects ever undertaken, reclaiming part of an entire sea. For centuries, the Dutch had learned to live with water, but every generation knew one frightening reality. The sea always waited for an opportunity to return. That opportunity came in January 1916. A powerful storm swept across the North Sea. Strong winds pushed enormous volumes of water toward the Dutch coastline. The Zuiderzee, a large saltwater inlet connected directly to the sea, became a giant funnel. Water levels rose rapidly. Dikes that had protected communities for generations began to fail. Several sections collapsed. Cold seawater rushed across farms, villages, and roads. Thousands of homes were damaged. Livestock drowned. Farmland was destroyed by saltwater contamination. Although the disaster was smaller than some later floods, it changed something far more important: the nation's mindset. Engineers realized they could no longer depend on repairing dikes after every storm. The entire coastline needed to be redesigned. Coincidentally, Europe was already in the middle of the First World War. The Netherlands remained neutral, but food shortages exposed another weakness. The country didn't have enough farmland to feed a growing population. Suddenly, one bold idea promised to solve two problems at once: protect the country from flooding and create thousands of square kilometers of new farmland. It sounded impossible, but Dutch engineer Cornelis Lely had already spent decades designing exactly such a plan. Now, the government was finally ready to build it. Lely's proposal was breathtaking in scale. Instead of fighting the sea in hundreds of different places, why not block an entire sea from the ocean? The plan called for constructing a massive barrier across the mouth of the Zuiderzee, more than 32 kilometers long. The structure would become known as the Afsluitdijk. Imagine building a highway, not across land, but straight through open water. Construction began in 1927. Workers first dumped enormous amounts of clay, sand, and boulders into the shallow seabed. Special barges carried millions of tons of material day and night. Gradually, the growing embankment stretched farther into the sea from both directions. As the two ends approached each other, currents became increasingly violent. The remaining gap acted like the neck of a funnel. Water rushed through with incredible force. Engineers had only a short window to close it. Finally, on May 28, 1932, the last opening was sealed. For the first time in history, the North Sea had been cut off from the Zuiderzee. Salt water slowly became freshwater. The newly formed IJsselmeer became one of Europe's largest freshwater lakes. The Netherlands had accomplished something almost unimaginable. It had permanently changed the geography of an entire country. But the Afsluitdijk was never the final goal. It was only the beginning. Because now, the real work could finally start. The Dutch weren't satisfied with protecting the land they already had. They wanted to create entirely new land. From the bottom of the sea itself. Once the sea was sealed off, engineers could begin draining enormous sections of the former seabed. Unlike the early windmill projects, this time they had powerful diesel engines, steam pumps, and later, electric pumping stations. The scale was unprecedented. Massive pumping facilities operated continuously for months, sometimes years, removing billions of cubic meters of water. As water levels dropped, something extraordinary emerged. Not an island, not a sandbar, but vast stretches of completely new land. The seabed slowly dried under the sun. Heavy machinery leveled the surface. Drainage canals were carefully laid out in perfect geometric patterns. Roads followed. Power lines appeared. Then farms, schools, hospitals, entire towns. This wasn't simply land reclamation. It was city planning before the land even existed. The largest achievement became Flevoland. Today, the world's largest artificial island and the Netherlands' youngest province. More than 400,000 people now live on land that, less than a century ago, lay beneath the sea. Modern cities like Almere and Lelystad stand where fishing boats once sailed. From the air, the landscape looks almost too perfect. Straight canals, perfectly aligned fields, carefully planned communities. Nothing happened by accident. Every road, every neighborhood, every farm was designed long before the first house was ever built. The Dutch had done something few civilizations in history could even imagine. They hadn't expanded into new territory. They had manufactured it. Despite the success of the Afsluitdijk, the Netherlands was still vulnerable. Much of the southwest remained protected by aging dikes, many built generations earlier. Then, on the night of January 31st, 1953, nature struck again. A powerful North Sea storm combined with an unusually high spring tide. The sea level rose far beyond what engineers had expected. Waves pounded the coastline for hours. One by one, the dikes began to fail. More than 1,800 people lost their lives. Over 70,000 were forced from their homes. Thousands of farms disappeared beneath salt water. The disaster shocked the world. For the Dutch, it became painfully clear that simply repairing old defenses was no longer enough. If the country wanted to survive the next century, it needed an entirely new approach. Not a stronger dike, an entirely new flood protection system. One that could defend an entire nation. That vision became known as the Delta Works. The Delta Works wasn't a single dam or one massive barrier. It was a nationwide engineering network. Storm surge barriers, massive locks, reinforced dikes, shipping gates, artificial islands, floodgates larger than office buildings. Together, they transformed the Dutch coastline into one of the safest in the world. One of its most remarkable structures is the Maasland storm surge barrier near Rotterdam. At first glance, it looks like two enormous steel arms resting beside a river. But each arm is longer than the Eiffel Tower is tall. When severe storms approach, the gates slowly swing into position. They meet in the center of the waterway, forming a temporary wall against the sea. After the storm passes, the gates reopen, allowing one of the world's busiest ports to operate normally again. Unlike traditional dams, the barrier stays open almost all the time. It closes only when absolutely necessary. Powerful computers continuously monitor weather forecasts, river flow, tides, and sea levels. When danger reaches a critical threshold, The system can close automatically. It's engineering that thinks before humans even have time to react. Today, the Delta Works is widely considered one of the greatest civil engineering achievements ever constructed. Not because it defeated the sea, but because it learned how to manage it. Even after centuries of innovation, the Dutch know the challenge isn't over. Climate change is raising global sea levels. Storms are becoming more intense. Rivers carry larger volumes of water during extreme rainfall. The country's response hasn't been to build infinitely higher walls. Instead, engineers have adopted a new philosophy: work with water instead of constantly fighting it. Across the Netherlands, rivers have been given more room to spread during floods. Floodplains are restored. Artificial wetlands absorb excess water. Some neighborhoods are built with floating homes. Modern pumping stations now rely on powerful electric systems, backed by real-time sensors, satellite data, and artificial intelligence. Thousands of measurements are collected every second. Water levels, rainfall, wind speed, river flow, groundwater pressure. These systems help engineers make decisions long before flooding becomes an emergency. The Dutch understand something many countries are only beginning to realize. Living with water isn't a temporary challenge. It's a permanent responsibility. When most nations wanted more land, they explored, they conquered, they expanded across continents. The Netherlands chose a different path. It looked at the sea and quietly asked, what if we built our own? Today, millions of people drive to work, land at airports, grow crops, and raise families on land that nature never intended to exist. Every road across Flevoland, every farm protected by a dike, every ship entering Rotterdam, every child playing below sea level is living proof of one extraordinary idea. Engineering can change geography, but perhaps the greatest lesson isn't about concrete, or pumps, or massive storm barriers. It's about persistence. For more than 1,000 years, generation after generation, the Dutch kept improving what the previous generation had built. They accepted that the sea would never disappear, and instead of trying to defeat it forever, they learned how to live beside it. That may be the Netherlands' greatest achievement, not reclaiming land from the sea, but earning the right to keep it. Because every single day, behind every dike, every pump, and every storm barrier, an entire country continues one of the longest engineering battles in human history. And so far, the Netherlands is still winning.